Bismillahirrahmanirrahim. Assalamu alaikum. My name is Fajar Iman Asmat and my department is chemistry. Today the topic of practical is to determine unknown concentration of copper in sample solution spectrophotometrically. Aim. The purpose of this experiment is to determine the concentration of an unknown copper to solution by spectrophotometric analysis. Chemicals and equipment required are spectrophotometer, coverts, set of copper to standards, one box lintless paper wipes, one copper or sample solution. Procedure. The wavelength should have been set to 810 nanometer. If not, notify your teacher. Obtain the cuvette containing water. This is often called the blank. Wipe off the cuvette with a lintless paper wipe. Place the cuvette containing water into the sample containing sample compartment with the white line facing towards the front. Close the cover and set the absorbance to 0 by moving the lower right hand dial. This dial is very sensitive, so only turn it a little bit at a time. Don't touch this dial again. Remove the cuvette of water. Obtain the cuvette labeled 1. It contains 1 gram per liter copper 2 solution. Wipe off this cuvette with a lintless paper wipe. Place the cuvette in the sample compartment with the white line facing forward. Close the cover. Write down the absorbance reading in the data table. Remove the cuvette. Repeat steps 6 to 10 to measure the absorbance of the other unknown solutions: 2 gram per liter, 3 gram per liter, 4 gram per liter, and 5 gram per liter. Obtain the cuvette containing the ore sample solution. Wipe off the cover with a lintless paper wipe. Place the cuvette in the sample compartment. Close the cover and record the absorbance. Remove the cuvette. Data manipulation and analysis. Prepare a graph with absorbance on the vertical axis up and down and concentration on the horizontal axis left to right. To plot the first point, go right along concentration axis until you come to 1. Move your pencil straight up until you reach the absorbance value you recorded. Place a mark at this point. This is point A. Plot the other 4 points B to E. Lay a ruler along the points on your graph. Try to get the ruler to touch as many of the points as possible. Use the ruler to draw a straight line through the data points. You will now use your graph and the absorbance values of your copper ore solutions to determine the concentration of your copper ore sample. Find the absorbance value you wrote down for the unknown ore sample. Go to the absorbance axis y-axis and place a mark at this value. Use a ruler to draw a line from the absorbance value on the y-axis over to the straight line you drew that connects your data points. Turn your ruler so that it goes up and down. Draw a line down to the x-axis. Where the vertical line connects with the x-axis is the concentration of your sample. Write down the number for this point in your data table under concentration of unknown ore sample. It will probably be a decimal number, so be careful. Now we will discuss the observations of this practical. This table consists of test tube number, concentration, and absorbance. Calculations. Graph shows the line graph of concentration versus absorbance graph. It will be a straight line graph. Given 0.2 molar copper 2 solution, M1V1 is equal to M2V2. M is equal to 0.08 molar and M is equal to 0.14 molar. Y is equal to Mx plus C. Concentration at this point is 0.055 and molarity is 3.267. Y is equal to 3.267 plus 0.055. Now, according to Beer's law, we will find the unknown concentration. After putting the values, the unknown concentration is 0.00092. As we know that the Beer's law states that the absorbance is directly proportional to the concentration, the resulting graph yields a straight line. The equation line, which is y is equal to 3.267x plus 0.055, can be used to determine the concentration of an unknown solution. Now we will discuss the result of this practical. The concentration of an unknown copper 2 solution by spectrophotometric analysis was determined. The concentration is 0.00153 molar and 0.0092 molar. Determination of copper 2 using atomic absorption spectrometry and adichrome blue black are loaded amberlite X801180 resin. A solid phase extraction system for pre-concentration and determination of copper in various samples has been proposed. Adichrome blue black are 1,2-hydroxy 1-naphthyl azo 2-naphtol 4-sulfonic acid loaded amberlite X801180 resin was used as solvent. Copper 2 ions were sorbed in the column filled with the chelating resin, and the elution of the retained analyte on the column was performed with 1 mole per liter nitric acid solution. Analytical parameters were evaluated, and the results were indicate that copper can be determined in the pH range of 3 to 10. Pre-concentration factor was 60 and optimum flow rate of sample was 4 ml per minute. The detection of limit based on the criteria of 3 seconds was found to be 1.3 milligram per liter, and the relative standard deviation of the method was 3.3% for 2.5 milligram per liter level of the analyte ion. The adsorption behavior of copper onto amberite XAD1180 can formally be described by Langmuir equation with a maximum adsorption capacity of 0.90 milligram per gram. The accuracy of the method was confirmed by analyzing a certified wastewater. A good agreement was found between the results and the certified values. This procedure was applied to the determination of copper in river and seawater dialysis solutions and fertilizer samples. This is the open structure of the Erichrome blue-black R reagent. And this is the adsorption isotherm of the copper 2 solution found by atomic absorption spectroscopy. This is the image of the instrument used in atomic absorption spectroscopy for the determination of a copper 2 solution. This is the reference from where I have taken this material. This was all from my side. Thank you.